Intelligent Transportation Systems Podcast. Hello everyone, I'm Javier Sanchez Medina from the IEEE Intelligent Transportation Systems Society. This is the first episode of this new initiative of our society, trying to bring the science cutting edge on transportation to everyone. We have prepared a very interesting first episode where the main course will be a really amazing interview with Professor Broggi from Italy. We will also have 2 mini sections with some news and also some transportation history. So please stay with us and enjoy it.
This is the news mini section. For this first episode news, we have the great pleasure to communicate that the ITSS member, Mr. Tsuneo Takahashi, has been recently awarded the 2013 prestigious IEEE Medal for Environmental and Safety Technologies for pioneering the development of navigation technology in automobiles. He has kindly donated his award to our society. We will hopefully have the honor of interviewing Mr. Takahashi at the IEEE Awards ceremony, so our listeners will likely enjoy it in a near future episode of this podcast. Another very good news we want to remark is the launching of ITS Now, a new online topical publication you will be able to find at the ITSS website. ITS Now is intended to be a one-stop source for free, limited-time access to articles from the Society publications and conference proceedings on a technical topic of timely relevance. Every 3 months, the editorial team will select 10 to 15 outstanding papers from our journals and conferences on the given topic, and they will be freely available at that website for a 3-month period. So, this is a very nice opportunity to read the nicest of our papers. Finally, there are a few close conferences we want to advertise. We will have the 2013 International Conference on Advanced Logistics and Transport on 29 to 31 May in Sousse, Tunisia. Then, we have the Intelligent Vehicle Symposium that will be held in Gold Coast, Australia on June 23 to 26. And last but not least, we've got the 16th Intelligent Transportation Systems Conference that will be held in The Hague, the Netherlands, on October 6 to 9. Please check out our website to find links to all these. We hope to meet you at some of them.
Transportation in history. What do dynamos, pointer telegraphs, electric elevators and trolleybus have in common? Their inventor, Ernest Werner von Siemens, father of the current Siemens company and prolific inventor in the end of the 19th century. This German electric engineer was responsible of many amazing developments, many firsts. He developed the layout of the first long-distance telegraph, the first dynamo, the first electric railway, the first electric street lights, and the first electric streetcar in 1881. Another fascinating invention of von Siemens was the electric elevator. In 1880, the first electric elevator was built for the Mannheim Pfalzgau Trade and Agricultural Exhibition. With a motor mounted on the bottom of the cab, Siemens' electric elevator used a gearing system to climb wall shafts fitted with racks. Although novel, this electric elevator was still too crude to compete with the existing steam-driven hydraulic elevator. Intended simply as an illustration of the broad applicability of his pioneering work in direct current traction motors, Siemens did not dedicate, after that demonstration at Mannheim, much effort to develop the electric elevators. It had to be the Otis Brothers and Company in 1889, those who take the lead by installing the first electric elevator machine in the Demarest building at the 5th Avenue in New York City. The total rise of that elevator was 21 meters at a speed of half a meter per second. In comparison with the current plans for a space elevator able to lift loads up to the geostationary orbit at 35,000 kilometers, that 21 meters may look humble, but it certainly was an earth-breaking technological development at the end of the 19th century. So the next time you get into an elevator and press your destination floor, remember an incredibly prolific German engineer was the creator of that time and effort convenient, comfortable box that takes you safe and sound hundreds of meters up in just a few seconds. Hello everyone. For this first podcast we have a great pleasure of interviewing Professor Alberto Broggi from the University of Parma in Italy. He runs a well-known spin-off company, VisLab, and he also has a wide experience as a volunteer of the IEEE Intelligent Transportation Systems Society, currently being past president for 2012. Hello, Professor Broggi.
Hello, everyone.
Well, we also have Professor Jeffrey Miller from the University of Alaska Anchorage. He will be helping out with this first interview. He serves as editor-in-chief for the IEEE Intelligent Transportation Systems magazine, where I think an article on one of the VisLab projects led by Professor Broggi will appear in the winter 2013 issue. Is that right? Hello, Jeffrey.
Yes, thanks, Javier. We will have an article in the winter 2013 issue.
Professor Broggi, it is a great pleasure to have you in our first episode. Could you please, Professor, introduce yourself to our listeners?
Oh, yes. Actually, I'm a full professor at Parma University, and I'm teaching artificial vision here at the engineering faculty. And I've been doing some research on intelligent vehicles since the mid-90s. And recently we also had launched a spin-off company, and the name is VisLab again, here at the University of Parma.
And could you please give us a panorama of what you do in your lab?
Yes, actually, we are doing some research on perception for vehicles, mainly for vehicles. Perception meaning that we are trying to perceive what's around the vehicle. So we put cameras, we put sensors, we put laser scanners and whatever on vehicles, so that we can gather a description of what's around the vehicle. And we do that for driver assistance systems and also for automatic driving. So these are two different projects. One is just for assisting the driver. The other one is for autonomous driving. And we have been doing that for a number of different vehicle prototypes. So not only cars or a vehicle that can drive on roads, but we also have been working on off-road vehicles, mining vehicles, so different kind of vehicles.
Professor Broggi, in 2010, your team accomplished an astonishing experiment, the VisLab Intercontinental Autonomous Challenge, where you sent 4 autonomous vehicles from Parma, Italy to the International Expo at Shanghai in China. Can you explain to our audience the details of this amazing challenge?
Yes, actually we have been, as I told you, we have been working on perception for vehicles, and we have been testing a lot in the last, let's say, 15 years or more. And what we did is that actually we tested the perception in some specific conditions, but we felt the need to do some more testing over very different conditions, very different road conditions, traffic conditions, weather conditions. So we organized this trip to test our perception layer And then so we actually at the very beginning we decided to go to Portugal or go to Norway, but because we wanted to test on a very long stretch of road. But eventually, in the end, we decided to go to the expo, the World Expo, which was in Shanghai. And that meant that we have been on the road for 3 months, traveling for almost 13,000 kilometers on very different conditions, like Russia, Kazakhstan, China. Those were very different conditions, very different traffic patterns, road conditions. So the real reason why we did that is that we wanted to really test our system and record the data. And we have recorded so many, terabytes of data. Now we have about 25 terabytes of data with all the data coming from the laser scanners, from the cameras, from the GPS and radio. So we have a very unique database. And with this unique database, we have been improving our algorithm even when we were back in laboratory here in Parma.
Well, Professor, as 2 years has passed since that challenge, I think our listeners would enjoy if you could tell us some insights you've acquired after processing that immense amount of data. Are you done with that, or are you still processing it?
Well, actually, we've been very, very optimistic at the very beginning because we wanted to, record everything and then travel the whole trip many times in order to improve the algorithms. But it happened that for us, it was a very difficult issue to record so much data and then process so much data. So actually, we do have processed a lot of those data, not all of them, because we still have some issues in how to really access the data because it's a huge amount of data. But nonetheless, we have been processing some parts of those data, the most important parts, the one in where the vehicle has been driving off-road, in traffic, or in bad weather, or in dust, smoke. So we have been cutting some slices of the data, and we have been processing those parts, and we have improved the algorithm. So right now we have a much better algorithm than the one that we used during the trip. And for example, we have been using stereo system, so 2 cameras processing images to get the 3D information about the world. And actually, we now have a much better stereo system that actually works in much more conditions than the one that we we tested on the trip.
That's great. And how about the future? Can you tell us more about your current and future projects?
Oh yes, we have we are close to get the new car. Because we want to have some more experiments, very specific experiments. We will be doing some more tests, actually not like the one that we did 2 years ago. So we will never travel to China again because it was too long and too stressful. But we want to do some other experiments to challenge our perception and our navigation system. But the most important thing would be that we would like to freeze our technology. Now we have reached something, a perception layer which delivers quite nice performance, and we would like to freeze this technology and produce some kind of embedded system, which includes the technology that we developed so far. So eventually build up some products, but I would like to continue doing the research with the new car, but also to stop, freeze the technology, develop something that can really be used on many different other prototypes, not only cars, but we are also thinking about agricultural vehicles and mining vehicles, construction vehicles, so different application domains.
Thank you, professors. Well, we're having now a short break, but more interesting stuff is coming from Professor Broggi after that, so stay tuned. If you like this podcast, could you help us spreading the voice? Visit our website at ITSPodcast.com www.cicei.com, and you'll find several ways to do it. We will now go on with the show. Stay with us. We're back with Professor Broggi talking about autonomous driving. Professor, in this podcast, we want to share with our audience the scientific developments in intelligent transportation systems, especially those published within our IEEE Intelligent Transportation Systems Society. Having that in mind, can you tell us what do you think our future cars will be? Will we still have the chance to drive, or will it be completely automatic and we only have to specify our destinations? Could you tell our listeners what are the real scientific developments in this sense?
Well, it's a difficult question actually, because it involves predicting the future. But as all the people, I think will agree, I would not rather put any limit to the development, both in the technology and the lifestyle. So if you think about that, well, I'm sure that someday we will all have autonomous cars. I'm sure, because there is no reason why we shouldn't have that. I'm not saying that will happen in the next 20 years, 30 years, maybe 50 years. I don't know when, but I'm sure one day all cars will be autonomous. There's no reason why it shouldn't be that way. Again, there are so many problems to solve yet. So not only perception, but also navigation and many other issues. But coming back to your question, there might be also the possibility for some people to drive, actually. But I think those will be kind of specific locations in which someone will have the possibility to drive, so locations or roads or some specific areas, just for fun. So we will keep the fun. But when you drive for work, when you need to reach your destination, when you need to commute every day, well, that will be very helpful to have autonomous cars for that.
I guess this is a very typical question to you, but do you dare to say when driverless vehicles will hit the market?
Well, this is again difficult, but we are very close to have driverless cars able to move in some easy and friendly scenarios. And I'm thinking about freeways, highways. In those situations, vehicles are flowing all in the same direction, more or less the same speed. There are no junctions, no traffic lights. So that's I guess it's an easy part. So we're very close to that. Even today, there are cars that are able to do some longitudinal control, lateral control, and if you put that together, we already have an autonomous car that can drive on normal roads. It's difficult. It's more difficult when you think about urban scenarios and more cluttered environments, more difficult. But maybe that in a handful of years, maybe 5, 6, 7, 8 years, we might have vehicles driving on highways. So maybe in some specific lanes on highways. If you talk about urban, maybe we need to wait until, maybe other 20, 25 years or something like that. Would that be reasonable?
So, Professor, there are always concerns about automated driving and common drivers using the system simultaneously. What do you think will happen with that? Will people accept that they'll have to trust their vehicle to keep them safe?
Well, let me put it in a different way. Maybe one day people will be worried when they ride on an autonomous car about the human-driven vehicles, because that will be the vehicles that will be more dangerous. So I'm thinking about a future in which all vehicles will be autonomous, safe, that will be very careful about fuel consumption. And if there will be some other vehicle around, so other human-driven vehicle, that will be the problem. So I'm seeing that as an exception to the rule.
And what do you think is the biggest problem as we approach to that scenario? What is the real challenge from your point of view?
Well, okay. There are anyway some difficult situation to be addressed. So maybe you can have a very powerful sensing system so that you'll be able to sense everything around the vehicle with 100% confidence in what you sense. Maybe you will have some nice predictions. So you have vehicle-to-vehicle communication, vehicle-to-infrastructure communication, so that your vehicle will be able to predict what's behind the curve or what's in front of the vehicle that you have in front. So think about those ideal world in which your vehicle will be 100% confident in what he sees and will be connected to the world, to the infrastructure, to the other vehicles. So even in this situation, this ideal situation, there are some problems that these are the main, the most common robotics problems. So what happens, for example, if the vehicle has to take some decision about that? So the vehicle is in front of a few people and has to decide whether to run over those people because it cannot avoid the accident, or just jump off a cliff and save the people in front, but kill the driver. So that's the usual problem that really needs to be addressed, because that's the difference between having local optimization or global optimization. By local optimization, I mean that the driver would like to optimize his own driving. While with global optimization, that means that the driver would like to, the system would like to optimize globally the fuel consumption, the travel time, all these indexes.
Professor, I guess you've been in a number of different driverless vehicles during these years. How was that? Did you feel safe?
Well, actually, we have been riding on autonomous cars for a number of years now. We started in about, I think, more than 15 years ago with the first project. The name was Argo, and we drove about 2,000 kilometers in Italy in semi-autonomous mode. And that was 15 years ago. So actually, in those years, we have been riding on a number of vehicles. So we really have some experience about that. But what I can tell you is that what we did 15 years ago. So when we traveled for the very first time on Italian roads, on real traffic, real conditions, with this vehicle, well, the first few kilometers were really, frightening. Because we didn't know what to expect from the vehicle. But after a couple of days, you already got some ideas about how the vehicle would move in such situation or another situation. And after a week, we really got very the vehicle was friendly, so we really could anticipate what the vehicle would have done in that particular situation. So it was very relaxing, and it was even too relaxing, because in the last few days we found ourselves talking together without really taking care about the driving. So at the very beginning it was frightening, then we were too much confident about the vehicle.
What about urban environments? Do you think we will eventually see unmanned vehicles circulating crowded cities? I'm thinking about Napoli in your country.
Yes, that's the difficult part, actually. Having vehicles driving in urban environments needs to have very complete perception of not only vehicles, but you have to perceive the presence of pedestrians, bicycles, scooters, and anything which can move in the urban environment. And another very important thing is that you really have to take care about unlawful behaviors. So some behaviors that should not happen, but if they happen, the vehicle should react in the correct way, which actually isn't usually the case for freeway driving. It's the driving which is more relaxed and more predictable. But when you talk about urban driving, there are so many different things that you have to take care about that it really makes the problem very complex. And well, if you want a prediction, I would say maybe 20, 25 years or something like that. It's difficult to make a prediction because the problem is really, really hard.
Well, thank you, Professor Broggi. It's been a great pleasure. We look forward to that article in the ITSS magazine.
Well, thank you so much.
Goodbye.
Bye.
Okay, bye.
And this concludes our first episode. Please visit our website in itsp.cicei.com. You'll find several ways to let us know what you think, and we are willing to listen to your improvement ideas. This podcast is sponsored by the IEEE Intelligent Transportation System Society, website designed and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain. Soundtrack developed by Rubicom. We'll be back soon, bringing you again the cutting edge of science at the Intelligent Transportation Systems Podcast. Thanks for listening and drive safe.